An executive committee consists of 11 members, 7 men and 4 women. 3 members are selected at random to attend a meeting in Hawaii. The names are drawn from a hat. What is the probability that all 3 selected are women? Okay, so do you see that this is 3 actions? We draw the first name. In fact, let me just bring them down here for us. So here are the 3 actions. We draw the first. So the first time they reach in the hat and draw a name, they're either going to get a man or a woman. And then the second time they reach in the hat, so that was the first draw, they're going to either get a man or a woman's name on the second draw. That's the second draw. And then they're going to draw a third time, and they're going to get a man or a woman the third time. So what we're learning, whoops, I can't talk and write here, is that every action requires a layer of branching. So there's the 3 draws from the hat. So we're pulling out of the hat 3 times, right? 3 members are selected at random. So you pull out one name, you pull out a second name, you pull out a third name. The first time you pull out in the hat, there are 7 men and 4 women, 11 names in the hat for the committee, for the executive committee. We're going to select 3 at random to attend a meeting in Hawaii, right? Everybody wants to go to the meeting in Hawaii, so they have to select the names at random from the hat. And they're asking us, what's the probability that all 3 selected are women? Well, the first draw, there's 7 men in there. So the chance you're going to get a man on the first draw is 7 out of 11. Woman is 4 out of 11 on the first draw. When you first reach in the hat, there's 7 men, 4 women. Then when you reach in the hat the second time, now if you go this way up here, that means you got a man out of the hat. Let me go down here. So originally there were 7 men and 4 women names in the hat. But if you go this road, that means you got a man out on the first draw. You get the name of a man on the first draw. So that leaves only 6 men names left in the hat for the second draw. So the chance you're going to get a man the second time would be 6 out of 10. And woman would be 4 out of 10 for the second draw if you got a man on the first draw. But if instead you got a woman on the first draw, let's go down this way, we're doing the first draw for woman. If you got a woman on the first draw, let's go back, it was originally 7 men and 4 women in the hat. If you got a woman out of a name of a woman out of the hat on the first draw, that would leave only 3 women in the hat for the second draw. So the chance you would get a man on the second draw after having got a woman on the first draw would be 7 out of 10, and woman would be 3 out of 10. See how it changes depending on what happened on the first draw? If you got a man on the first draw, then that changes the chance of a man or woman on the second draw, versus if you got a woman on the first draw, that changes what's in the hat for the chances of getting a man or woman on the second draw. Now let's go to the third draw. You got to follow the tree, the path, as you go through this. So if we got a man on the first draw and a man on the second draw, what would be left in the hat at this point? So remember, originally we had 7 men and, 4 women names in the hat. So if we did man and then man, that means we'd take 2 men names out of the hat. If we got man the first time and man the second time, if we're going that way, that means that left in the hat is 5 men names and 4 women. That would mean 5 out of 9 is the chance you're going to get a man out the third time. And 4 out of 9 is the chance you're going to get a woman out on the third draw after having got a man on the first one and a man on the second draw. That would leave 5 men and 4 women names in the hat. Now let's do the next option. If instead you got a man on the first draw and a woman on the second draw, what would that leave in the hat? Well, again, originally there were 7 men and 4 women. If we got a man and a woman, that would leave 6 and 3. So this would be 6 out of 9 for man, 3 out of 9 for getting woman on the third draw after having got a man first draw and a woman second draw. Now let's come down here. What if we got a woman on the first draw and a man on the second draw? Well, that would leave the same thing, 6 and 3. So this would be 6 out of 9, 3 out of 9. What if we got a woman on the first draw and a woman on the second draw? Well, that'll change things a little bit. So again, originally we had 7 men and 4 women, but if we got woman on the first draw and woman on the second, that would only leave 2 women names left. So the chance of getting man on the third would be very likely, 7 out of 9. Woman would be 2 out of 9. Okay, let's put all these together. So this is the man, man, man road. This is the man, man, woman road. This is the man, woman, right? Can you follow it? Man, woman, man road. This is the man, woman, woman road. This is the woman on the first draw, man on the second draw, man on the third, woman on the first, man on the second, woman on the third, a woman on the first, a woman on the second, man on the third, and woman on the first, woman on the second, and woman on the third. Now, we can figure out any of these probabilities by just multiplying along the branches to that answer. So now, let's figure it out. What do they want? They want the probability that all 3 selected are women. So all they want is this one, woman, 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 which is 4/11 times 3/10 times 2/9. 4/11 times 3/10 times 2/9. So what do we get? You can cross-cancel or multiply. So I'll just multiply. 4 times 3 is 12 times 2 is 24. I just multiplied this times this. 4 times 3 times 2. On the bottom, 11 times 10 times 9, 990. And then you got to reduce that fraction. You can divide top and bottom by, I guess 6. So then you get 4, and let me see, if you divide by 2 and 3, divide by 6. I don't know what that is. Let's use my calculator. So 990 divided by 6, I'm getting 165. 4 over 165. So that's the reduced fraction. The probability, that's the chance, that's the probability you're going to get 3 women names out of that hat for the people going to Hawaii. When you select 3 names out of the hat that originally started with 7 men and 4 women, the chance of woman, 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 chance of woman the first time is 4/11, and then that leaves 3/10 left in the hat and 2/9. Multiply those together, woman, woman, woman. 4 out of 165, not very likely, you're going to get 3 women names.